I think finally I'm at the end of what has been a bit of a saga with RS485. I've already recorded a kind of intro for this video, but I'm recording this as an intro to the intro because there were things I didn't know when I started that I know now, and they're hidden because the video is kind of a journey, a week of pain in my life trying to get RS485 working, and I wouldn't want to inflict that on anyone. There are two key things I think that are hidden amongst the things I learn as I go along now, and it's going to be such a long video, it's not really fair to have them needle in a haystack style. So the first is I had a lot of trouble with long extension cables on USB. So if you've got an Arduino that's a long way away from say that you need a 10-meter extension cable for, I had a lot of problems getting Arduinos connected to PCs on that kind of length of cable and communicating consistently, and that brought inconsistencies. The other is in the RS485 sense, the RS485 to TTL modules, the little ones that connect between the data bus and the Arduino, they are very easy to short and to break, effectively to fry, and they don't tell you that they've been fried. The little light comes on and they appear outwardly to act normal, but my experience with them is, and this I can't prove it, it's quite just down to experience I guess, but even though they look like they're working fine, underneath they're causing havoc on your RS485 bus. They are flooding your Arduino with data, possibly flooding the RS485 bus as well. So if when you're wiring up, if you realize that you've wired one of those TTL modules up incorrectly, or you think you might have shorted it, take it down to a breadboard and test it and make sure, because I suspect that one of those dodgy modules on an RS485 network will bring the whole network down and nothing will work. So that's the quick that's the lessons, that's the quick way of communicating it. And if you fancy a sleep, then there's probably an hour's worth of me getting there the long way. So I'm in the process of building a new layout in my loft of reasonable size, and the intention is, the hope is, to use JMRI, to use servos for point motors, relays for frog management, and then introduce lots of sensors and block detection and all those kind of clever things. But I'd be lying if I said, even to get to this stage, which is just one loop and a few points working, hasn't been incredibly painful, or at least time consuming, and yeah, has involved a lot of head scratching and frustration. So as most of the issues now I think seem to be getting themselves sorted out, I thought it might be a good idea, before I move on to other stuff and forget everything, I try and go through all of the issues that I encountered, because I think from what I've seen, there are a lot of resources and videos online that demonstrate how to do this on a breadboard with very short cables and a very kind of controlled environment. My experience has been that was easy to recreate, but actually transitioning that onto an actual layout with a lot more distance between all the little components is a whole different kettle of fish, and that's really where I've struggled. So I'm going to try and go right back to the start, what I did to begin with, the issues I encountered, and hopefully not only how I resolved them, but how I went about trying to resolve them, in case that helps too. So, starting right at the start, I guess, my layout is DCC controlled, and therefore it needs a DCC command station to power the track and to run trains. And the command station component of that is this, an Arduino with a motor shield and a piece of software running on it called DCC++, which is a little bit of a play on the name, kind of DCC controller written in C++. It's really the easiest thing that I've implemented of everything I've done. It's very straightforward. You just buy what you need to buy, you plug the wires in where it tells you to plug the wires in, you download a bit of software that you need to download, you upload it onto the Arduino, and it just works, which is fantastic. So the a typical DCC command station is comprised of three components. I think there is what they call the throttle, and that's the human interface. That's how the person running the layout, communicates to the command station what they want to happen, which train they want to move effectively, the user interface, the thing they interact with that enables them to instruct the command station. On a lot of DCC control command stations that are bought all in one, like an ECOS for example has a touch screen, that's the throttle. There are other DCC systems that have a handheld device that has a dial and numbers on it. You put the number of the loco in and you turn a dial to drive it. They are throttles. And in my case, the throttle is the monitor and the mouse. There are also other ways of doing it. There are apps that run on tablets that effectively allow me to select, if I'm using a mouse and a keyboard on the computer, or if I'm using a tablet or phone, the result is the same. It enables me to select a loco and control its direction and speed, and a lot of other things as well. But that's the basis of it. So that is the throttle. The next thing is the command station, and the command station is the thing that takes those instructions from the human and translates them into digital messages destined for the track, for the feed, for ultimately for a decoder. And in my case here, the command station really is JMRI, the software, because that's the piece of software that offers up the throttles, takes the input that I give them, whether it's sliding a slider or pressing a button, whatever it is, takes them and then translates them into instructions for the decoder. The third component of a DCC command station is the booster, and that really is what the Arduino is doing here. What the booster does, the Arduino is connected to a power supply, and the track feed is coming out, but it's also connected to the PC. So eventually the third part, once the human has said which train they want to drive and how fast, what direction, whatever else, once the JMRI software has translated that into messages destined for the decoder, the Arduino takes those messages, combines them with the power feed and sends them out on the track. So it sends power to the track, but also sends specific messages to specific trains saying, this is what I want you to do. And that's the basic setup of DCC, and that's as far as my layout will go with DCC, effectively driving trains. Everything else, turnouts, block detection, everything else will be handled on a completely separate system and could run perfectly well with DC. It doesn't have to be DCC. So really, as far as DCC is concerned, that's the extent of DCC's involvement in my layout. So really, as far as DCC is concerned, that's it. It's relatively straightforward, even the Arduino approach, because I guess primarily because everybody's going to use it the same way. You only need one of them. You connect it to the computer in the same way, you connect it to the power supply in the same way, and you connect it to the track in the same way. And really, in most cases, the size of the layout doesn't really change what you need. Even if you just got a little circle of R3 track, whatever, you still need the same thing as you would if you have a bigger layout. And that makes the DCC side of things very simple, and really puts it to bed because it's completely separate from everything else as well. So that's the DCC side of my layout, and that's it done. But I also want to do some other stuff. I want to do these point motors and block detection and automation and everything else that's really quite interesting. But I've found it very complex and confusing and frustrating mainly because it's different for everybody, and there's no whereas with the Arduino, with the DCC control, there was just a set of instructions you could follow and it would work. You don't have that on the accessory side because everybody's requirements are different. Everybody wants to do things in a different way, and what works and is well documented for one person isn't necessarily going to work for another, or for another layout. And also there isn't much documentation out there, and I've been quite confused by what there is. So I'm gonna try and go through how I approached it, how I tried to keep things simple for as long as I could, and then how, when things got complicated and didn't work, how I kind of tried to strip it back again to make it simple, to just rule out all of the unknowns, and try and keep a handle on what was happening, why it was happening, and why what wasn't happening, and why stuff wasn't happening as well. So if you search around on Google for instructions and demonstrations and examples of using all this technology with a layout, you'll tend to come to a few common terms. First is JMRI, the Java Model Railway Interface, which is a piece of software. It's vast, it's very clever, and it does a lot of stuff. But it can also, it's free as well, but it can be daunting, I think, to start with. It's still daunting for me, even though I've been using it for years. You'll also very quickly come across the acronym CMRI, which I think stands for the Chubb Model Railway Interface, after the person who invented it. What CMRI is effectively is a way of allowing lots of different devices that are designed to control accessories such as point motors. It doesn't have to be servos, all kinds of different accessories. A way of facilitating them communicating with JMRI, so that if you have turnouts in JMRI and someone clicks a button that says I want this turnout to throw, it gives JMRI, I guess very similarly to how the booster works in a command station sense, it gives JMRI the outlet, the way out for its instructions to get to the devices and components that they need to get to. And really, this is where it starts to get complicated. I've used Arduinos, there's one here, and there are quite a lot of examples on the internet of sample breadboard type connections, and they are very useful and informative to start with. You'll see a breadboard, just a tiny little component board with a few wires clicked in, snapped into it, connected to an Arduino, connected to a power supply, connected to a servo motor, and a couple of other bits of technology. And you'll see if a button gets clicked, the thing, the servo moves, and that's excellent, and it's the start point. And I did that, and I got it working, and it was interesting, and it motivated me to get going with this layout, I think. But the transition from that tiny breadboard to actually implementing all that on a layout is huge. And there are a lot of factors and variables and gotchas sat there waiting, and also just how to increase the scale of it. Questions about how do I increase the scale of this if I've just got some tiny little wires connected into a breadboard. How do I make that? How do I increase the size of that? How do I scale it up so that it works on a layout with all these wires? So you have JMRI installed on your computer and you have it running, and you want accessories. You want ultimately to be able to control all your point motors and whatever else, and get sensor information back into JMRI. The common way to do that now is using these Arduinos. This is an Arduino Mega with a what's called a sensor shield on it. I think that's the most popular way, most common way of implementing CMRI now in JMRI. And an Arduino is basically just a very simple computer. it can connect to a PC or a Mac, I guess, using USB, and all that's really, well, that has two purposes. The first one is to get what they call a sketch onto the Arduino. Now, an Arduino is a very simple computer in the sense that all it can do is obey one set of instructions, and that set of instructions is called a sketch, and it's transferred onto the Arduino by USB from Arduino software on the computer. It can only do one thing, and that is run that sketch, and every sketch has two basic features, components to them. It has the setup function, which is what the Arduino will do once when it is switched on, when it gets power, when it starts. And then it has the loop function, which it will then just carry on doing forever. And that's all it can do. It can only have one of those sketches on it at any one time. It can't switch between two. It will just, basically, it will do two things when you turn it on. First is the things you told it to do when it turns on. Second is the things you told it to just carry on doing forever. And in terms of CMRI and being a CMRI node and being the conduit between JMRI and all of the servo motors and everything else, essentially what it does is when it starts, it initializes everything, like the board that controls the servos over there, and kind of gets itself set up, establishes its connection to CMRI, which currently on this one is through USB. And then the loop is just about constantly checking all of the values in CMRI, which I'll come to later. So there's a value in CMRI for each set of points. So for each set of points it's connected to, this one will only ever be connected to 8 sets of points, eight point motors through this board. So what this does in its loop, once it's gone through its setup, is effectively it says, I'm aware of these 8-point motors that I'm controlling, and I know that they have a unique ID within JMRI. So I'm just going to constantly check JMRI for these 8-point motors, and if I detect a change in their status from thrown to closed, closed to thrown, I will change this point motor. I will run this servo motor to change the points from open to thrown, and that's it. It just sits there. This one, because it's connected, or will be connected to 8 sets of points, that's all it does. And everything on top of that is kind of an addition. So, for example, this has got what's called a sensor shield on it. This is an Arduino Mega underneath here, and it has lots of pins around the edge. Now, almost everything that eventually gets connected to and is controlled by this Arduino will need some form of power, or at least connecting to the ground circuit if it's independently powered. And really, all this shield that does, this blue thing that's sat on the top of it, does is make it easier to connect stuff, because for every pin, whereas they're in these kind of little black containers around the edge on the actual Arduino, for every pin put a 5-volt power supply and a ground next to it, so that it's easier to connect stuff to it. Basically, it's just a kind of a human help. It doesn't add anything to the way the Arduino works. It just makes it easier to connect stuff. So that's what this shield is on top here. So the first obstacles to overcome, I think, when transitioning from having all this set up on a little breadboard on a desk to being in an actual layout room, which can be quite big, is how am I going to connect everything up when it's all so much further away? Those little breadboard wires are barely 30 centimeters long. How am I going to transition that so that everything still connects up when it's all a long way away? And of course, I mean, even on your desk, you sat next to your computer. The computer is down there, maybe 3 meters now away from this first Arduino that I set up. And so, and in trying to keep it simple, I kind of knew that in the end I'm maybe going to have 3, 4, 5 Arduinos dotted around this layout, maybe more, and that therefore at some point in the future USB probably won't do it for me, because that's too many USB cables. What I didn't factor in, and what soon became apparent, is Arduinos don't like USB extension cables. This one gets away with it. I think this is a 3 meter cable. Any more than that, and Arduinos start behaving very strangely. Computer doesn't recognize them half the time you plug them in. The computer times out writing the sketch to them. I've ended up with 2 bricked Arduinos just because I used long extension cables. So very important factor early on is certainly keep it simple. Don't go from a little breadboard with a few USB connections to a big RS485 bus, because you're introducing so many unknowns, so many variables in there. It's going to be difficult to troubleshoot. So come in the first set of Arduino, first Arduino you set up on a layout, use USB, because it rules out that whole world of RS485 pain. But beware, don't use a long extension cable. Set it up close to the computer. Like I said, I got away with this one a bit, and that it was lucky. I only set it up here because there's 4 sets of points up there with point motors, and the point motor's very short. Point motor cables are very short, servo motor cables. So I wanted to minimize the amount of DuPont cables I had to crimp and put together, because that's quite time consuming and quite wasteful as well. I've only got maybe a 70% success rate with crimping DuPont wires. So get a USB connection, keep the same connections to these boards that were on the breadboard, and then just extend crimp extension cables to connect up the servo motors. Also, I think when I started, I just had servo motors connected directly to the connections on the board, so that I could again rule out problems, because I'm very capable of incorrectly crimping a DuPont extension cable. So rule them out as well. Have motors connected to the board to start with, to make sure that they work, and then at least you know if you connect an extension cable to it when it's in situ and it doesn't work, the chances are, if you're like me, you've crimped a dodgy cable. Then we come to power supplies. At least power supplies for all the additional components. We'll worry about Arduino power supplies later. I didn't want lots of 5-volt power supplies hanging around. I considered, in fact, I did pull cables for a 5-volt bus wire around the layout, but too many devices pulling off that cable would probably cause me problems anyway. So I've gone for what might be an approach that I'm going to change later, in that I just have one 5-volt power supply, and here it is, and it's plugged into this PWM driver board. And what this driver board has, it has 16 connections, 16 3-pin connections that are those yellow, red and black ones down there. The yellow is the signal, that's the PWM instruction. The red is 5 volts and the black is ground. And it has this separate 5-volt connection so that it can power all of these servo motors. But I only use 8 of them because I also have this relay system down here for electro frogs, which I've kind of covered in another video. So once I got onto these last 8 connections, which are for the relays, they only need the signal pin connected, the yellow one, because it's just a simple instruction that's going down to this. But this relay also needs a 5-volt power supply. So rather than start splitting this one up, putting it through a splitter or whatever, I thought what I've actually got here, although the servo motors connect to all 3 of these and take their 5 volts and use that to move, the relay pins are only using the top signal one, which leaves me 8 5-volt connections effectively. So the 5-volt connection that the relay uses is actually connected to the red and black on pin 8, if it's 0 indexed, pin 8 on there. And then also moving on further, and I'll demonstrate this later, I also use more of these last 8 effectively 5-volt supplies for other components, like the TTL module. Once we get into RS485, is powered from 2 of these as well, just because they're all there and they're empty, and if they are, there's no point in crimping more DuPont cables, having cables that will connect in there and have DuPont sockets on the end. So for the time being, I'm just sticking stuff onto those 5-volt supplies there. But I quickly, over the other side of the layout, started adding more points and more parts of the layout, and there's no way that the cables, the connectors on the PWM driver board here, I'm not going to start pulling another 8 or crimping another 8 of these cables to go the 10 meters it would take to go around the edge of the loft and over to the setting there. So very quickly I ended up with another Arduino on the network over the other side. And this was where the world of pain really started. I initially came with the same approach of, well, I'll do it with USB because I want to make sure it works before I start messing with RS485. So it's a bit further away from the computer. It's maybe 7 or 8 meters away now. And to start with, I just borrowed the extension cable I was using for the one on the other side, the first one, which wasn't long enough. So then I plugged another USB extension cable into it and plugged the cable into the Arduino here. But immediately I started seeing problems. I was getting USB device not recognized when I connected the Arduino up. Only sometimes. Occasionally it would work, occasionally it wouldn't work. Even when it did work and it did connect and it did get recognized, writing a sketch would fail halfway through and time out. And eventually, I think because of that, I bricked 2 Arduinos. It took me a while to cotton on to the fact that it was those USB extension cables. I did then buy a USB repeater 10 meter extension cable, but it was no better. I was still getting consistent and unexplained connection issues between the Arduino and the computer. So it quickly became apparent to me that I needed to switch to RS485 in order to rule out that USB connection. And the idea with RS485 is you effectively create a data bus, those 2 wires there, running the length of your layout, which carries all of the instructions from JMRI that used to go through USB cables to every specific Arduino. This way you put all of the data for all the Arduinos on those 2 wires, you connect the Arduinos to those 2 wires, and with the help of a little adapter called a TTL converter, the Arduinos, instead of communicating through their USB socket, they communicate through serial pins, and they get the messages that are intended for them. Immediately as I started looking through videos and instructions, it might be my lack of understanding of electronics, but I started to see what I thought were conflicting messages and confusing messages and unclear messages, specifically around a common ground connection between all devices, as some people recommended. So what I did to start with, as well as pulling this data bus on the USB adapter, if it focuses, there's also a 5-volt and ground connection. So I pulled a 5-volt and ground bus wire, pair of wires as well, connected them to the sockets on here, and at least try to use them as a common ground. Maybe not 5-volt, but at least have them connected to the ground. Now I started experiencing even more issues after that. I was getting short circuits, I was getting very strange behavior. At some point the computer just went bonkers. So I've disconnected them for now. I don't know if all the problems before were created by the USB, but the USB extension cable, but for the time being I've disconnected those wires, and I might connect the ground cable back in if I need to, if there really does need to be a common ground between all the Arduinos and all of their components, but for the time being I'm going to leave them disconnected. So this twisted pink and purple bus wire coming out the back of the USB connector over there runs all the way around the layout and ends up, because I could only get 10 meters worth of cable, terminates around here, in fact right there, And for the time being, I've got two shorter, same colour wires connected in there that go into the TTL adapter at the top there in those two screwable things. If the light will let me show them there. There they are. And then there are also, this is the these two connectors here are 5 volts and ground, which, as I explained before, are pulling the 5 volts from unused pins on the bottom half of this PWM driver board. And it also has a few cables there that are connected to communication pins on the Arduino. After spending a good while getting this second Arduino board, I guess, all wired up and set up for not only JMRI but also RS485, I had a world of trouble and pain trying to get it to work. I was just getting nothing from it, and I spent a day or two like that and really got to a point where there were just, again, so many variables, so many things that could have gone wrong, and I couldn't work out how I would prove they'd gone wrong, and also a lot of things I didn't know whether they worked in the first place. And because there were so many things that could have gone wrong and none of which I could isolate and prove, I decided to go back, take it all apart, take it back downstairs, get it in my office and put it back on a breadboard, and so that I could just start eliminate all the point motors, use the initial Arduino sketch that Michael, I can't remember his surname, sorry, I'll put it on after, Madleech, the guy who wrote the RS485 library and a couple of the other ones. He's got a web page, I'll include it, a link to it, where he explains the basics of RS485 and Arduinos and JMRI and kind of gets you started. So I went right back to the start of that. I set it all up on a breadboard. I eliminated all the servo motors. I just purely got to a point where I wanted to be able to turn the Arduino system LED on and off from JMRI, and so I took it all downstairs and got that working straight away, which was quite a surprise in RS485 because I'd struggled for so long with RS485. I really wasn't expecting that to work. So once that worked, I brought the breadboard up into the loft and connected it up as it was, with absolutely no changes to it, or as few as possible, to, you know, just the Arduino without the sensor shield on it, and them all just cabled together with little cables, and nothing to do. The relay wasn't connected, just the Arduino and the TTL module, because that's needed for the RS485. So I brought it upstairs and I used short cables as well, because I thought the cables could be a problem. So I got it all working as it was back when it was brought back up in the loft, and then I started to replace the breadboard components one by one with the components that would actually be in use in the loft. So I'd started off with short cables connecting it. So I pulled some cables directly from the TTL board to the computer over there, just directly across the floor. They're probably still lying around somewhere, just so that I could start to eliminate long cables and, you know, work out if they were the problem. So by that stage, because I'd had it working on the breadboard, I knew that the USB to RS485 adapter in the PC was working, and I knew that the components on that board were working, the TTL module, the Arduino itself, and the 5 volt supply was getting through to it, because that was all working. But obviously that was using tiny little cables for the RS485 bus wire. So once I knew the core components were working, I thought, right, okay, I'm just going to start adding in the major components, the big components, the layout size components, one by one, until it stops working. So I quickly established, after doing that the main cause of all my problems, again, was this long USB cable, because downstairs with a tiny little USB cable plugged into the PC in my office, the uploads were working all the time. The sketches were being uploaded to the Arduino all the time. It was always recognized by Windows when I plugged it in, and there wasn't a peep of a problem from it. And then about 10 minutes after I got back up here and I was trying different things, plugged it in with the extension, USB extension cable. This is the end of it here. It was a repeater one. It wasn't in the end a kind of a patched together one. And yeah, within 10 minutes I was starting to get those errors again. So I ditched the whole idea of trying to connect the Arduino here into the PC over there. And that in itself is a lesson, because that's what's no more than maybe 5 meters. I was using a 10-meter extension cable, but you soon kind of need long cables like that. So that's a big lesson, I think, in anyone using or intending to use an Arduino for layout control with a PC. You can't, even if you've got USB extension cables, you can't let your Arduino drift too far away from your PC if you're intending not to use RS485. However, I was intending to use RS485, so I made a decision to bring a laptop up so that I could connect directly to the Arduino to upload sketches to it, but I would then rely on RS485 for the actual communication with the PC and with JMRI. So once I'd established that a very likely cause of the problem was the USB cable, everything started to fall into place. But I still went one by one. So once I'd got direct cables from here, which were only about maybe 3 or 4 meters long, over to the PC working, and the whole RS485, the LED still worked, the LED on the Arduino still worked. So then I plugged it into the actual bus cables. You can just see the pink and purple ones coming over the top of the board there, and that still worked. It was still working fine. So then I plugged the servo motors back in, and they still worked fine, and the relays, and they were working fine. And I just suddenly found myself, without really kind of realizing it, with an RS485 bus set up and working, because one by one I replaced components and it all still worked. So everything was the same as it had been before. So yeah, the blame has to lie thoroughly at the door of that USB extension cable, I think. But what I also did, and this became a big help, and I also almost kind of accidentally stumbled upon it, I think, was once I'd got the Arduino working on an RS485 bus, it freed up its serial bus, because when you're using Arduino directly connected to the PC for JMRI and CMRI with the USB cable, the serial bus on the Arduino is locked by JMRI and you can't use it. And the serial bus is what you would use for console output, which can be really helpful for debugging. So what I realized was, if the Arduino's talking happily on its new RS485 bus to CMRI, then its serial bus is free. So I started to add debug lines to the sketch that was controlling the Arduino, so that I could tell what that enabled me to do was I could tell if the Arduino was receiving messages from CMRI on the RS485 bus. Before I could establish that, if I clicked move turnout in JMRI and nothing happened on the turnout, then I had this whole path to go through. Is it JMRI? Is it the connection? Have I got the connection settings wrong in JMRI, or is my RS485 USB adapter working, or are my bus cables too long, or do I have a dodgy connection connecting my bus cables to the TTL module? Is the TTL module dodgy? Are the cables connecting the TTL module to the Arduino the wrong way around or dodgy? Have I cabled them up incorrectly? Is it the Arduino itself? Is there a bug in the sketch? Is it something to do with the connection to the sensor shield? Is it the connection between the sensor shield and the PWM driver board? Or is it the connection between the PWM driver board and the servo motor? And that's overwhelming. That's an overwhelming list of things to have to check. So what I've found with now being able to use the serial bus is I can output any message that the Arduino receives an RS485, if it's one it thinks it has to act on, I can output it to the board. So even if nothing happens, if the turnout doesn't move, if the servo motor doesn't respond, I can at least see if the Arduino got the message, and that splits the amount of investigation I have to do in half, because if I know it got the message, I know my RS485 bus is working okay, so then I can concentrate on the connections on that board. So I've got a little example here. So I've got my tablet with the 4 turnouts that I've currently got set up on JMRI, and I've got the I've got that desktop recording, so hopefully I'll be able to zoom in a little bit and give a better picture of this. But that's the terminal window open and monitoring. So now if I click this one, and you hear the turnout move, but you can also see on the console output, I'm getting a message on the turnout. So if that on the serial monitor, so if that motor hadn't moved, hadn't responded to me pressing that button, then at least I would know that the message got to the Arduino and that the problem was somewhere in that cabling. And I do have a few other turnouts here, and if I press them, if I press a few of them away here, there's no sound, there's no motor moving, and there's nothing coming up on that window either. So that means something for those 3 turnouts that I've added there, the message isn't getting, the motors might be wired up fine, and that's irrelevant, because the console, the sketch that's running on the Arduino is not receiving the instruction to throw the turnouts. And actually that came as a bit of a surprise to me when I was preparing to record this video. I was expecting there to be a response on them, and I was expecting there to be a response on there, and immediately that got me thinking, and I think it's actually that it's just not, it's only expecting, the sketch is only expecting to be managing one servo, so it's not even looking for messages on subsequent ones. That's what I think it is anyway, and that's where I look. But it's a good example of, I press the button here and I expect movement there, and if I don't get movement on that console window, it means the sketch isn't getting the message to throw the servo, and it's nothing to do with the connections from the Arduino onwards. So now I've got a bit of confidence in the RS485 bus, it's time to cut the cord on this original Arduino here and disconnect it from USB and get it plumbed into the RS485 bus, which conveniently is travelling straight above its head there. So all I really need to do, I think, to get this working, or to get it configured to a point where it might work, is I've got to cut this cable, and I've got to splice out to effectively the same as a DCC bus, splice out 2 dropper wires, bring them down here, get another TTL module, and get that wired up the same way as the first one. I've done some DuPont wiring on a little cable here. Effectively all this is it's a cable that I cut at about 2/3 distance, and the extra third that got cut I soldered onto a split in the middle. So this is effectively my the 2 pins that need to be connected together and go into pin 2 on the Arduino, the RE and DE pins. It's just 2 cables that are soldered together, so these 2 will go on the RE and DE pins, they get joined there into one cable, and that will go onto pin 2 on the Arduino. I've now spliced a couple of cables into the bus wire up there and got a currently unpowered TTL converter module dangling down off them, and the good news at the minute is over there the turnout is still throwing, so first potential disaster averted. Splicing into these cables hasn't damaged them or weakened them in any way, and I'm still getting data passing through them. So next step is to simply cable up this TTL module, get it connected to the Arduino, and see if we can start pulling data onto it. So first of all, here's my little jumper cable, and the 2 sockets on the end have gone into the RE and DE pins on the output end of the TTL module, and they've plugged into the signal pin for pin number 2 on the sensor shield board, which is effectively the Arduino pin 2. So I'll next cable up the rest of the other 2 data cables. That's my TTL module now powered up. There's the 2 input data cables coming from the bus up at the top. There's on that side there's also a ground and 5 volts, which I'm still getting from some of the 5 volt and ground pins that I don't use over on the PWM board, which it's kind of got 2 advantages. First of all, I don't need to split a power supply or run another power supply, but also this board is already earthed, grounded with the Arduino, so I don't need to worry about grounding all devices. This one, as soon as it gets connected to this board, which is connected, has a ground connection to the Arduino. This is already on the same ground circuit as the Arduino. Just after I recorded that last bit of video, when I was all set for my moment of glory, connecting that second node up to the RS485 network, as soon as I got that second node spliced up and connected to the TTL converter, everything broke again. Not only did the new node that I'd added, that had been working perfectly well on USB all that time, not respond to anything at all, but the first node that had been working perfectly well up to that point stopped working as well. That was a couple of days ago, and I've been scratching my head and trying everything ever since to work out what on earth could have gone wrong, and I think I finally worked it out. I think so far it's these TTL converter modules. It seems that they are so easy to break, and once they're broken, they won't tell you they're broken, but they will destroy your world for you. So I was labouring away. I only had 4 of them, and I'd kind of wondered at certain points if I was working with broken ones, but the little light came on when I plugged them in, so I kind of assumed that they did. And then yesterday, just kind of as a last resort, I swapped one. I had one new one left, and I swapped it in place of an old one, and suddenly one of the nodes came to life again. So I'm going to share my experiences. I'm kind of quite positive I want to get up and get these plugged into nodes now, but what I've done is down here I've set the breadboard up again, and I ordered 6 new TTL modules. And first of all, I plugged all 4 of the old ones, which are over there in a scrapyard somewhere, all 4 of the old ones into this board. And this is again the basic Michael Adams madleech blink, effectively. So you set up a light in JMRI, you set up the RS485 connections, and all you want is when you turn your light on, the LED on the Arduino board to come on. And for all 4 of those ones that I'd been labouring away with for the last week, no LED on this board anymore. The new ones have arrived today, and plugged the first 2 in, and for both of them the LED has come on. And then, just to be absolutely certain, with exactly the same circuit, I went back to those old 4 again, plugged them in one by one, and none of them came on. Now this is observational, and I can't prove it, and maybe at some point I will go on to prove it, but I think what's happening is this TTL board, if it experiences any kind of a short or a misconnection or something happens to it that it can't cope with and can't handle, it doesn't tell you it's gone bonkers, but it goes bonkers. And the issue I was having, that I put down to a USB cable with attempting to upload sketches to the Arduino and them timing out, I think is caused by a faulty TTL adapter. Because what I experienced was, when I was trying to upload them, even on a very short USB cable, they were timing out, and after a while and giving an error message. So I ended up just pulling the data cables out of the Arduino, those ones that are connected to the TTL one, and suddenly the sketch would upload fine. So I've now tried with this TTL adapter plugged into the circuit that works, and I can get the light to blink. Again, the sketch uploads fine, there's no timeout and no issue. So what I'm starting to suspect that these TTL modules are doing when they break is effectively a denial of service to the whole RS485 network. I think what's happening is when they break, instead of doing nothing, they do everything. They just send loads of rubbish out on the serial pins, which is going down these wires into the Arduino and stopping it from doing anything, because it just seems to be getting so much rubbish on the serial pins. Again, this is pure conjecture. I can't prove it. This is just anecdotal from what I've seen, or what I think I'm seeing, and it's just flooding the Arduino and it can't do anything. And because of that, I'm also wondering if at the same time as sending rubbish out in one direction, or at certain points, it's also sending rubbish out in the other direction. So if you've got a network of RS485 nodes with Arduinos on the end of them and these TTL adapters on the end, if there's one on the network that's broken, I think it's possible that it's just sending so much rubbish out onto the network that effectively all the other ones are just being flooded as well. So I'm at least now in a situation where I know that the TTL adapters I was slaving away trying to fix the last 2 days, trying to get the network working with the last 2 days, are definitely fried, and I have two here that are definitely functional. So I'm now going to head up to the loft with a little bit more optimism than I've had of late and see if I can finally get an RS485 network running consistently. We might actually have a happy ending. Just literally 10 minutes. I mean, this has been down for a week now. I've been struggling with this CMRI stuff for a week, and 15 minutes after the new batch of these TTL converter modules arrived, I now have 2 nodes working on the CMRI network for the first time. I've had one working without the other, I've had the other working without the first one, but I've never had 2 working together. So this really now feels like a breakthrough. I obviously need to do something to tidy that thing, stop it dangling in midair, but for the time being, I'm just enjoying the fact that this works. In the break, in the time it took for me to for Amazon to deliver the extra set of modules, I have edited the video kind of up to this point. So I've been through and I've seen all the mistakes. I'm not, these TTL modules, I'm not blaming anyone but myself for them. I've got bad eyesight. I don't always wear the reading glasses when I'm up in the loft. It can be dark, crawling under baseboards and that kind of thing. All of these boards have failed because I've done something stupid. I'm in absolutely no doubt about that. Even at the point, these we just knocked a cable there. These connector cables now for the TTL module are actually in the signal pin, not the ground pin. That probably fried the one that I was about to try and connect, and I was fully optimistic that it was going to work. Yesterday I'd got direct cables, they're still down there on the floor, direct cables connected to each of them, and I'd proven that they work directly, so I was absolutely confident that it was going to work. So I obviously, with there being direct cables in, I disconnected the pink and purple bus wires from the USB adapter down there, and so having proven that each of these worked by dragging cables directly to each of them independently, I was absolutely confident that the bus cable would work. Went and connected it all up down there, turned it all on, neither of them worked, and I was working on these pins, like checking the cables. I put my fingers on it. I thought, goodness me, this is hot. Are these really meant to run that hot? And then actually when I went and checked down there, I hadn't connected the pink and purple cables to the A and B connectors on that USB thing. I connected them to ground and 5 volts. So yeah, that's that put paid to my last 2, and that was the point when I immediately went and ordered some more. But it's yeah, it's human error. I fully acknowledge that, but yeah, I'm just relieved that I've got to the point, and cause the journey maybe is always worth it when you get to the end as well, in that I know a heck of a lot more about this now than I had if I just wired it all up and it had worked in the first place. I've done a lot of research, a lot of reading, so I'm in a better place. Now I'm at the end of it, hopefully, but it was a heck of a journey. I haven't been able to run trains since this whole RS485 saga started, mainly because this train here had stopped across a set of points. Just coincidentally, that was where it stopped when I was finished, and I left the loft the last time I was running it. And when JMRI started the next time, it opened that set of points that the coach's wheels are sat on there. So I couldn't get the rest of the train over it, and I couldn't close the set of points, and I didn't want to just do it programmatically, connect a laptop to it and hack it. So I've been stuck with a train set on this set of points for a few days because I couldn't open and close them, but I now can. So I even get to run a train as a result of this, and I've got my little board here just to prove it, hopefully. So let's go to move a couple on here. I'll go for the first one just so I don't derail that train again, and that's a good noise and a good sign. And then the big test would be the one at the bottom, because that's on the other node. So let's give that one a go. Yeah, and the one behind me is moving as well. So absolutely uncategorically, for the first time, I have two JMRI nodes working consistently.